Welcome back to Deeksha Vedantu YouTube channel. I hope you all are doing great. Alright, now be honest with me for a second. How many of you look at a circuit diagram and go, ew, this again? Ma'am, I don't even know how to start solving these questions, right? There are multiple ammeter, voltmeter, resistors, batteries, cells, and then there are arrows in which current is flowing, and there are wires that are coming from places they shouldn't be coming from at the first. Okay, I know. You know how? Because I was there at your position. I hated these diagrams, I swear. I'm not just saying for the sake of the video. I used to hate these circuit diagrams, but you know what I was lagging? It was not my concepts. It was not my practice sessions. What I was lagging is the correct approach. You know, here's the thing. If you have the right approach to solve these circuit diagrams, these combination of resistors, then you will be able to solve these diagrams like this. And maybe they will be a little bit fun. Because these are not that hard. It's just in our mind and the way they look that we get feared by them. Okay, so in this video I'll give you that exact right approach that my students used to ace these circuit diagrams in my exams. So let's start. So see, for these combinations, we know that resistances can be put into two types of combinations. What are these? These are series combination and parallel combination. We know that. What is series combination? When two or three resistors are connected in a single line in series, that is called a series combination of resistors. If they are emerging from a single point and they are coming back to that point, okay, and the other resistor is not connected from the end of the previous resistor but in those between those points, then this combination is called a parallel combination. How to remember where current remains same, voltage remains same, where current divides, voltage divides, all that mess is very simple. We have studied SI units, right? You all studied SI units. You know what SI units means. Now the trick is that for series we can remember SI. SI is what? For series combination, current remains same. That if my 5 ampere current is passing from first resistor, then from second also it will be 5, in third also it will be 5. And if current remains same, what divides? Voltage divides. Voltage does not remain same, and hence different is voltage, current is same for series combination. Now just invert the digits. In place of S we have parallel, so P, and inversion of current, the opposite of current in this scenario is, instead of current we can write voltage. So for parallel, voltage remains same, and what divides? Whatever left is divides, current divides, and voltage remains same. Understood the trick? SI units, series, current remains same, and then opposite of those in parallel, voltage remains same. Correct? Clear till now? Now let's see the questions. Okay, there are just 3 steps that you need to follow. Every time you look at a circuit, every time you look at a combination, a series, a parallel, whatever circuit, 3 steps. First one, ma'am, what is the first step? We need to find the equivalent resistance. However resistances are there in a circuit, be it 10, be it 100, be it 1000, you just need to use the formula for equivalent resistance for series, for parallels, and you need to find the equivalent resistance of that whole circuit. Correct? Okay, then we'll find the current. Note down these steps in your notebook and you'll see how they'll make sense when we do these questions. Okay, first equivalent resistance, then find the current in that whole circuit, and then whatever we are required, so let's say we are required to find the voltage. After that, in the third step we will find the voltage. First equivalent resistance, second current in that circuit, and third will be whatever we are asked, our required voltage. So let's see, first step is find the equivalent resistance. See, in this we are given, this is a series combination. My friend, Tell me in the comments if anyone has any doubt. Is this a series combination? Very clearly we know. It has 1 ohm resistance, 2 ohm resistance and 6 ohm resistance, and we have a 4 volt battery. Okay, let's see, we need to find the current in this diagram. Okay, so what I'll do is, I know that in series the formula is R1 plus R2 plus R3, correct? R1 is 1, R2 is 2, R3 is 6. 1 plus 2 plus 6, and it gives us 9 ohm. Can I remove all these 3 resistors and put a 9 ohm resistor instead of this 3 resistors? Correct. So I'll remove these resistors, and instead of that I'll just put one resistor which has a resistance of 9 ohm. Correct. Now I have voltage, I have my resistance. What law can I use? Ohm's law. Very good. Ohm's law I can use, and it states that V, potential difference, equals to IR, and we have V as 4 volt. Okay, we have V as 4 volt. We had resistance. What did we find out? This is 9 ohm. V equals to IR gives us 4 volt equals to I into 9, and then current comes out to be 4 by 9 ampere. Correct? Was it easy or not? What we did? See, what we did? We found out the equivalent resistance first, and we found out then current. It's that simple. Clear? Series done. Let's move on to the parallel combination. Now, even in parallel, what we need to find? We need to find the equivalent resistance. See, in this case, let's see. There are 2 resistors in series as well, but it's very simple, ma'am. We have found out how to solve series resistor now. So we will just add these resistors. 5 plus 10, this is 15 ohm. So instead of this circuit, we can just make a single resistor of 15 ohm. Correct? Instead of 5 ohm and 10 ohm, we can put a single resistor of 15 ohm. Similarly, for 4 and 6, instead of that, we can put a single resistor of 10 ohm. You know addition, right? I'm guessing all of my 10th class students know addition. 6 plus 4, 10. 5 plus how much? 10 is 15. Now, we have 2 resistors. Let me make this diagram again. This is my diagram. In here, I have a resistance of 15 ohm, correct? And here, I have now a resistance of, see, 10 ohm. Very good. And the rest of the circuit is same. And this is our 4 volt battery. Again. Okay. Now, what will I do? I will find the equivalent resistance of, now these are not in series, these are in parallel, and we know, ma'am, still we know the formula for parallel equivalent resistance as well, which is 1 by R1 plus 1 by R2. 1 by R1, let's say, is 15, and 1 by R2 is now 1 by 10. If we take the LCM, we can just take 30. So 2 plus 3. This is 1 by RP. Remember, not RP. Don't do this mistake, okay? 1 by RP hence is 5 by 30. 1 by RP is 5 by 30. And if we divide, we'll get 6. So RP is 6. Now, can you see? Instead of having 4 resistors in my circuit, now I just have one resistance, which is equivalent of all those 4 resistance, which means all those 4 resistance were producing a hindrance to the current. The 6 ohm will produce the same amount of opposite flow, the hindrance to our current in the circuit. Now we have RP as 6 ohm. Again, we know, ma'am, Ohm's law. What does it says? V equals to I. R. V we had 4 only. I we need to find, and resistance is 6 volt. Correct? Then our current will be 4 divided by 6, which will be 2 by 3 ampere. Correct? Am I correct? Let me add one more thing in this particular question, let's say. Now, let's say they say that you found the current, you found the equivalent resistance. What I need is the voltage. See, in this whole parallel circuit, let's look at this. This is a parallel circuit and we know SI and PV. So in PV, in parallel circuit, voltage remains same. So these are in parallel. So here also I will have 4 volt and here also I will have 4 volt. Now I know, but ma'am, in parallel voltage remains same. But that means current is different. So if I ask you, tell me the current in this 15 ohm resistance, what will happen? A current will flow in this circuit, right? It will go, but at this point it will divide. In this, let's say in this 15 ohm, I1 goes, and in this 10 ohm resistor, I2 current passes. Okay, I2 current passes. Now, if I ask you, what is the amount of current that passes just in 15 ohm resistance? In here, when we found out the current, this current passes from 6 ohm resistor, which was this. Okay, here was our battery, whatever. Okay, this is a 6 ohm resistor. In total of one 6 ohm resistor, we have 2/3 ampere current passing. But if I ask you, I don't want the current of 6 ampere resistance. Tell me the current in 15 ohm resistance. I want that. Okay, don't fool me. I want the current in 15 ampere. So what will I do? Now I know 15 ampere. So I have a resistance. Okay, I know the value of resistance. Now is the good thing. PV, in parallel voltage remains the same. So here we know 4 volt goes, 4 volt goes. So in this particular circuit, we also know the value of voltage, which is 4 volt. So if I try to find out the current V equals to IR, I will be 4/15 ampere in this case instead of 2/3 ampere, and hence it proves that in parallel current is different. Okay. Don't just give me this. That was 6 ohm. That was a complete different circuit. Don't fool me, ma'am. Okay, let me find out the current in this, the lower segment of resistance. In here, the resistance is what? Tell me. It's 10 ohm. Okay, but parallel voltage remains same. So voltage is 4 volt. Again, ma'am, Om Baba ki Jai, V equals to IR. And then we have R as 10. We need to find the I, and we have voltage as 4. So see carefully. In this case, we get I equals to 4/10 ampere. In 15 ohm, we get current as 4/15 ampere. But in case of 10 ohm resistance, we get current as 4/10 ampere. Okay, enough for today. Thoda sa little portion is still left. You understood? Of course, ma'am, if the resistance is different, current will be different. If I am pushing someone, okay, someone is pushing me, a child is pushing me, of course he cannot push me, right? But if a big guy, a big woman or man is pushing me, they will push me very easily, right? That's the same case in current. If a 10 ohm resistance is, see, current came of 15 ampere and he goes to a resistance of 5 ampere. He will feel some resistance. But if he goes to the resistance of 50 ampere, of course he will feel more resistance, right? That's common sense, ma'am. You just made a lecture on that. Okay, let's move to the very interesting part, which is mixed. Although we did do the previous question as mixed one, but let's see this question now. Does it still feel that heavy? Maybe it does. Let's break it down. Okay, so first solve what we'll do, we'll just find out the equivalent resistance. How will we do that? Let's see in step by step. Mind, in this type of questions, find the kind of resistances that you can solve first, which you think is easy. I'll tell you how. Let's see, these two resistances are in series. If I just add them, 6 plus 4, it will be 10 ohm. Correct? It was easy. So instead of these two resistors, now I have only one resistor. My this diagram becomes what? It becomes something like this. Instead of 2, I just have only 1 now. Correct? And instead of 6 and 4 ohm, I have 10 ohm. And I had 10 ohm, 10 ohm and 5 ohm. See? It got a little bit simple. The circuit goes a little bit simple. Now we have these two in parallel. We can clearly see this, right? These two are in parallel. So let me find the equivalent resistance of this. Let's name this A and B. Let me find the equivalent resistance between A and B. Okay. So I know for parallel the formula is 1 by R1 plus 1 by R2. R1 is what? 10 ohm, 1 by 10, and R2 is also 1 by 10. So 1 by RAB, correct? 1 by RAB becomes what? 2 by 10, 1 by 5. So RAB, if we reciprocate it, RAB comes out to be 5 ohm. Correct? So let me make this circuit again. 5, 10. Okay. Now instead of that circuit, we just have 3 resistances left. How? Let me show you. So this was 5, 10, 10, 5, 10. But instead of these two 10 and 10, we just have 1 5 now. Correct? This is also 5. So see, we had 5 resistances first, then we shorten the circuit into 4 resistances. Now we again shorten the circuit into only 3 resistances. Okay, great. It's a little bit of fun. Come on, it's a little bit of fun. Okay, now we just add them. Now we know these are in series, ma'am. These cannot be more simplified. These are in series, and we know in series we can directly add the resistances R1, R2 plus R3, which is 5 plus 5 plus 10, which is 20 ohm. So now can I make the circuit into something like this? 20 ohm. See, is it the simplest circuit now to ever exist? Just a voltage source, a resistant, and we need to find the current. We know the voltage, we know the voltage, correct? And it's 20 ohm. Again, ohm baba comes into play. V is 4 volt and current is current we need to find, resistance is 20 ohm and current will be 4 by 20, which is 1 by 5 ampere, my dear friend. Is it correct? We just solved a massive circuit, a circuit which consisted of 5, and mind you, these kind of questions have come in board exams. I'm just not picking it from anywhere. Mind you, this combination had 4 resistances in them. It had series combination, parallel combination, and then they were mixed together. Okay, like a halwa. So what we did it? We solved those resistances, and with the help of equivalence, with the help of using parallel, equivalent resistance of parallel, series combination, what we did? We simplified that big messy circuit into this small one. Is it correct now? Is it correct? Okay. And my dear children, oof, that is done. Now let me know in the comments, try solving some resistances questions. If you can't, post them in the comments. I'll look into them, and I'll give you the solution in next my lectures or lives. Mind you, we are going live, and I'm going live next week on Thursday, I guess. There will be a schedule put on the channel, and we will solve PYQs. We know this time we are getting competency based questions, and we'll solve PYQs on that channel of 1 marker competency based question, previous year questions from the chapter electricity. Do not forget to join that live. You can ask doubts, you can give answers. It will be a bit competitive. You will give the answers, I'll ask the questions and all that kind of session. Okay, also to get that notification, we are going live for other subjects as well. To get that notification, go join our WhatsApp channel, and do not forget to subscribe the channel for more such videos, because your boards are coming and we are here to help you. Okay, tata, bye bye.